All right, welcome back to the lab. Many of you have asked, so I figured I'd do one. Let's talk about nuclear radiation and nuclear bombs. First and foremost, we need to have the understanding of fission. Now, nuclear fission is a splitting of a radioactive nuclei into two smaller nuclei. Now, when we say radioactive, what that means is that they are radioactive isotopes. So they are the same element, but they have different number of neutrons. So that's what an isotope is. It's an atom of the same element, but it has a different number of neutrons. Now the process all starts with a neutron. A lowly neutron is fired at a nuclei. And what that does is it becomes radioactive. Now when that happens, that nuclei is going to split into two smaller nuclei. But at the same time, this is also giving off about 2 or 3 extra neutrons. And the system's going to repeat itself. So all of these neutrons are then going to go out, and they're going to join with other atoms and other nuclei to become more radioactive, and then that's going to go on and on and on. This is where things get interesting, and this is when things get dangerous. Now, this is what we call a chain reaction, which basically means that one neutron firing into that one nuclei, and then decaying, and then sending off all of those other nuclei, about 2 or 3, is then going to form more radioactive isotopes. And that's going to keep going. And this is why nuclear fission and nuclear fusion can supply a lot of energy. Now, nuclear fission takes place in nuclear bombs. Sometimes fusion as well, depending on what kind of a bomb you're looking at. But it all comes down to nuclear fission. We have a neutron that is causing a nuclei to become radioactive, heavier, okay, like uranium, plutonium, things like that. And now what's going to happen is that chain reaction is going to keep going. And this is why your nuclear fallout is so massive. This is also a reason why things like Chernobyl, like other radioactive disasters, Hiroshima, things like that are so dangerous. The chain reaction, the ongoing exponential energy that's been given out is massive. Okay? So, what have we learned today? Nuclear fission. The decay of a radioactive nuclei into two smaller ones, but giving out multiple neutrons, so the chain reaction keeps going. But before we go, assignment time. In the comments, I want you to write the definition for fusion and fission. They are two separate things. Do some research, and I'll see you next time here in the lab.